Okay, so this evening, before I go on with any further electronics things, well, in particular my little Pong game, I'm going to talk a bit about something that I briefly mentioned in a video recently, which I think was this thing, the 4049 flip-flop ongoing saga, that about pull-up resistors. And I believe I'm using them here, so you can see them kind of here. So I'm going to steal one of these, because then I don't have to work out what kind of resistor to use. But before we do, well, the whole point of this video is, what is the point of that? Why should we have these things? So here I've got set up a 4049, another one. But this time, so I'm going to have to get out my screwdriver and bring this up quite close. So this is the output of one of the flip-flops, and it's going into this LED, and that's going to light up depending on what the input is. And the input is the next pin along, which is what this little green wire is currently attached to, but not actually attached to anything in particular. And so this is kind of important. Wait, this is, well, what I'm going to show you is kind of important and kind of interesting. So because this input here is not actually tied to anything, you won't get a consistent output. And we're going to show this, so hopefully it all works. It kind of looks like it's flickering from here. I don't know if that's going to show up. It's kind of strange. But, in fact, if I get my hand close, so I'm not actually touching the wire, so you can see that, maybe you can't see, that when so hold on, hopefully, there, the light's gone out, but then I might be able to get it to come back on again without actually touching it, and it's come back on again. And I had this little drone thing. I was going to see if I could interfere with it enough with the motors. This drone doesn't work very well, so don't worry too much about that. Come on, wake up. I haven't turned the drone on yet, have I? So it's gone back out again. So it's just going on and off. So look at that. I haven't done anything. Oh yeah, it reacts to that. So as I get closer and further away, flip it around. So in fact, I can detect the orientation of the LED, of the drone, just by turning it around, which is quite neat when you think about it. So the whole point of that, hold on, it might actually react when the, it's not going to react to my thing now, is it? Hello, wake up! I think this thing won't even turn off. Alright, one last try. Okay, it's not going to work. I think it's out of batteries. I knew I was supposed to charge it up. But the point is that you can see that interference from other, so if I plug it into something, so if I plug it into the positive rail, it turns off like it should because it's inverting it, and if I plug it into the negative rail, or the ground, it turns on like it should, and it's nice and strong. That's how it should look when you're not doing anything. And I was going to do some, so I'm giving away my things. So this is kind of what the circuit looks like. What we're going to do in a second is we want to put a button in. And so when the button's not pressed is what I'm trying to get to. I'm not really, this is going all over the show, this video. But I want to do this. So we're gonna plug the oscilloscope with this not so great oscilloscope, but it's not too bad. Like, it does what I want it to do, which is to illustrate some very simple concepts. So I'm going to attach it to there. Even that can kind of interfere with it when it's finished. Wakey wakey. Alright, skip, whatever. Alright, so hopefully it's going to positive. It was all fine before. Now what's happening? Every single time this was all working out sweet. And of course I can't remember how to change everything back. It's not working, it's not picking anything up. Should have just used the other thing. No, that's alright. Everything is matching up. 0.5 seconds. 0.1. Done. it's still a bit on the, hold on, it's all the way up the top. Yeah. So that is kind of the output, really. So I think we're kind of getting it. I'll move it down slowly. Takes a while to react. So even when it's on, it's actually, so you can kind of see my hand. That is, I need to turn the trigger on. Well, we're not gonna, alright. Okay. Norm, done. Alright. That's not what I wanted. Now it's all mucked up. But anyway, the whole point is you can see that the signal is terribly messy. So there we go. There's a good example of it. It's actually going up and down all the time. So even though the light's on, it's going on and off really, really fast. And I can kind of see it from here. I don't think it's going to show up in the camera. So my whole point is if the input isn't actually tied to anything, you're going to see a terrible looking input. So it's a mess. It's all over the show and it's not good. So the question then becomes, how do I turn this thing off? I'm going to unplug you for a second, and I'm going to unplug you, and I'm going to put this to the side. I'm just going to power it off. Alright. And almost dropped the whole thing on the floor. Alright, so anyway, that's the point. So if I was, where's my little button gone? I had a little button, and I dropped it on the floor. Oh, well I had that all prepared, but it was too small and then it fell on the floor. Well, this video is not going the way I had hoped. Oh, it's right there. I hadn't dropped it on the floor. It was right here. So here's my little button. So I'm going to attach my button, and we're going to get the final circuit, which is, so the input's going to go to the button. And then I'm going to supply 5 volts into the button. Where's my little collection of wires? We'll just use this one. So, oh, that was a terrible, there we go, that's fine. Alright, so looking at the thing, if I press the button, that's not what it's supposed to do, it's not plugged in. Alright, okay, it goes off. Actually, put it there. So pressing the button is supposed to make the light go off. So if I press it, the light does stay off. So it's connected to the positive rail, and it's going into the button, in through this wire, and into the input to this IC. And when I press it, it does go off. But when I let go, it doesn't always come back on again, and it doesn't always stay off. So basically it's indeterminate, and now it won't come back on again. There we go, it came back on. I just touched the LED and it came back on. And it goes back off. Touch it again, touch something, and it will turn back on. So how are the two solutions to doing this? Well, this is where pull up and pull down resistors come in. So as I said before, there are 2 ways of doing this. The one way is to use a pull down resistor. So that's what this one here is. So here's my positive voltage here. It's going into the button, and the button is going into my pin on my IC or my pin on my Arduino or microcontroller. And so it's going into there, but we also have another path going to ground. But this path here has a reasonably large, or can be quite significantly large, resistor in the way. So in this case I wrote down 10K. I suspect you can get away with this, a significantly larger one. And there are good reasons for why you might want it to be larger. But, well, I can see we can kind of experiment. But in this case here, what will happen is when this button is not pressed, there is a path pulling it down to ground. So the input going into here will read as low. But when we press the button, then the voltage that you're going to read at this point. So the one thing that I really have to stress as to why this, so the only reason I'm doing this video is I want to talk about the maths kind of behind it, or the sort of physics behind it. remember that the impedance of these pins, or the resistance for now, is very, very, very high. So very little current is going to flow into the actual IC through this pin. So you can kind of imagine it as it splitting off into two circuits coming in from here, but one of them has a very high resistance in comparison to this. So if you remember back to the parallel circuit stuff, when you had a parallel circuit where one path was a very, very high resistance compared to the other path, then the overall resistance is effectively whatever the lower path is. But in this case it doesn't really matter. All that really matters is no matter what the voltage is here, there's no resistance coming in via here. So the voltage you're going to read at this point is very close to the voltage that was coming in, if it's not in fact the same voltage, even though there's another resistor in the way. I don't know why I think this is something this has kind of confused me at the beginning, because I sort of felt that, well, you know, if you put positive voltage in there, and then you've got to store this, because remember the important thing here is that this voltage is coming in here and then it's going down to ground through this resistor, and a very small amount might be going, or a small amount of current might actually go into the IC, so it detects what the voltage is. So this thing is sensitive to the voltage, but it's not actually taking a lot of current. And I just felt when I first got into electronics, it was a little bit like, well, hold on a second, isn't all the current going to go into there, and isn't this thing only going to see 0 volts because there's a much easier path, and so nothing's going to go into there. But it's just reading the voltage at this point, and because all the voltage is going across this resistor here, it's still relatively high. So if it was 5 volts in, it would be 5 volts around here. In fact, there will be the same voltage because they're assuming that your wire has very low resistance. There's nothing actually in the path between the high voltage and here. The tricky thing is, I mean, I guess maybe slightly different, is just another way of doing this. So this is the pull-down resistor. So in this case here, the resistor by default is pulling the current down, pulling this pin towards the ground voltage or a lower voltage. But the other way of doing it is to swap things around. So in this case here, you have, from the positive voltage, you have automatically a path with a 10k or whatever large value resistor in the way going into the pin. So if you haven't pressed a button, it's the same thing as saying this thing doesn't exist, right? So if the button hasn't been pushed, all you've got is 5 volts coming into here and nothing's happening. And then when you press the button, there's a path going down to ground. And the path to ground is from, if you look from here, the path from this pin here to ground is pretty much a straight route, and this one's got a big resistor in the way. So this is called a pull-up resistor because it's by default pulling it up. So you can kind of say it's weakly pulling it up to the top. Actually, I've just realized I'm not going to be able to no, we can explain this, I think, quite well. Yeah, so the important reason why this is the other way of doing it, and if you use an Arduino or a microcontroller, they often have built-in pull-up resistors, so you can turn that on. So when you're reading your digital pin, you can set the mode to be one with a pull-up resistor activated. And so in this case here, when you do this, so if you have a button and you're trying to detect it, the button forces it to be a low voltage and not a high voltage like you do in this case here. And this one here sort of makes me feel a little bit strange, right? Because, now why do I think it's strange? It's funny now that I talk about it, that maybe because I've done it so much, it doesn't seem very strange. It's like, well, of course it's going to read 0 voltage down here. Because remember, this has a very high, so the same kind of thing here, is this has a very high voltage. A very high voltage, a very high resistance. The only thing that would make me nervous, right, is, well, say that thing is not there. Put that there. A random piece of, random breadboard. Now, the thing is, say the actual resistance on this was close to 100k, or 10k, sorry. So it was very similar to this resistance here. Then the voltage that's in this bit here, so it would take, this is the only path to ground, is to actually go through the IC. So it's going to go 5 volts across a 10k resistor and then across another internal 10k resistor to ground within the IC. Well, the actual voltage here will be about 2.5 volts if you start off with 5 volts, say. So 5 volts, you have to cross 10k down to 2.5 volts, and then another 10k takes you down to 0 volts. And if it would be worse, if this was like 5k and this was 10k, then you'd actually have dropped down to about, well, one third of what, let's just say there's 6 volts coming in, then there'd be 2 volts here, which would then register as a low. So even though you're coming in here with 5 volts at the top, or 6 volts say, just to make the maths easy, 6 volts in here, you're still going to read a low voltage here because you've got this 10k here. But this doesn't happen because the actual sort of resistance you can kind of imagine is effectively huge, like 100 million or something. I don't know what it is really, but it's way higher than any resistor you're going to use. So you probably can get away with quite high resistances here, like 100k or 1 million. I don't know. I've never tried it. I just put a 10k in usually. And everyone else seems to, so I'm assuming that's the way you should do it. But we'll, I don't think I have any. Where's my little box? Okay, we've got some resistors here, so we'll quickly finish this up by just trying this out. So we want this to go off when we push the button, and we want it to stay off without any funny business, without me just moving my finger around there for the light to come back on again. Now actually I want the light on, but I want it to come back on again when I let go of the button. So the button turns the light off because it's an inverter, and when I let go the light should come back on. So and it doesn't work at the moment because we have no pull up or pull down resistors. So we're going to use, what have we got here, a 36k. So we'll use these ones here. These are sitting, I know I can't use those, they haven't been opened. Alright, I've got these little random collection of ICs sitting here on the desk. That's 1k, that's the reason you want it, well, we'll do this one. This is 680k, so we'll see if this works. The reason you want a high resistance is that when you press the button down, most of the current's going to go through here. So you could be using a reasonable amount of current if this is too low. So when you're holding down the button, you're just wasting battery power for no reason at all. So as long as this is really, quite, well, it doesn't actually matter what it is, but you want it to be high enough that you're not using a lot of power when you push the button down. But you don't want it to be too high, because if it's too high, then you'd have that problem where you have the voltage being split up between those two things. But as I said, the resistance is so high on the IC that you can get away with pretty much any resistor you use. So we're gonna find out if that's true. So all we have to do in order to put one in. So this part here, this is not very well done because there's not a lot of room. So I'm going to change this slightly. I'm going to shift this into the middle. Hopefully it fits. So that I've then got a bit more room to move. So where did I put my IC? So these things, remember, on your buttons, these two pins are actually connected and those two pins are connected. So this side here is actually connected straight through to the IC. So anything I put on this side is actually going to go straight into here. So this is where we can put in our pull up or pull down. So when I push the button, I want it to go high as an input, so I plugged it into the high voltage. So I want a pull down resistor to pull it down to ground by default. So I'm going to put my very high resistance resistor in there, and then I'm going to plug it into the negative rail on the other side. So it's come back on, and it's a nice strong sturdy on. Let's just see if I press the button, it goes off, and then it comes back on and it goes off, and it comes back on and it goes off. So that's the pull down resistor. So a 680k resistor seems to work just fine. So let's now try in doing it with a pull up resistor. So this is a pull down resistor. Did I say pull up? I should have said pull down. That's a pull down resistor because you're pulling it down to ground by default. So we're going to take that one out, and then we're going to change our button so that the button is actually going to create a path to ground. So when I press the button now, the light comes on, but then it's a little bit iffy afterwards. Well, that's going to stay on, isn't it? Well, I want it to go off. Alright, so yeah, that's right. So remember, we're inverting it. So when I press the button and there's a positive voltage going into that pin, what's coming out is the opposite. So there'll be a low voltage. So because I've got a low voltage going in, then a high voltage is going to come out and the light's going to come on. But if I have a high voltage, it's very hard to get these things around the right way. I'm so sorry. But now we're going to put my pull-up resistor into the high rail, into the positive rail, and then I'm going to plug it back into this line here, which is going straight to the IC. So it's bypassing the button because this line goes into here. This pin is connected to that pin straight away, so that's just by default going through there. So I hope that makes sense. You have to just play around with buttons, you'll get what I mean. And so now the light has gone out, which is what we wanted, because there is a connection to the high or the positive voltage. So now when I press the button, the light comes on, the light goes off. Light comes on, light goes off. Light comes on, light goes off. And I've done that by connecting it to ground. So when the button is pressed, it's actually connected to the low voltage, the ground. And when it's released, it's got a very weak connection, or a high resistance connection to the positive side. So I think that hopefully that makes a lot of sense, and it's pretty straightforward, and you don't feel a bit strange about it anymore. And I think it's when you do it long, for a while, you kind of forget or why some things seemed very confusing. So I don't know if anyone else is going to find it a bit nervous, or a bit nervous about it, but I remember feeling that way, so I hope that made you feel happy about it. So just remember that the ICs, or the CMOS ones, have a very high resistance for each of the input pins, so you can do this kind of stuff and be happy. So cool, thanks for watching that, and like, share and subscribe.